Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our modern C++ series. In today's lesson, we're going to be talking about the preprocessor and macros in the C++ language. I'm going to go ahead and show you a few useful tips and some useful macros that you can use in C++ to help you primarily with debugging. Now, with that said, macros do have sort of a reputation in the C and the C++ language because it can be a little bit difficult to debug, because we're essentially just inserting code at the preprocessor level, and that can often be tricky as macros expand. So we do want to use them judiciously, that is to say with caution, and make sure that we're using these features in the right way. That said, though, you are going to run across them in source code bases, and occasionally they can be useful. So I want to go ahead and show you how to use this tool, and you can go ahead and decide if it's useful in your project. So what I'm going to go ahead and do is first give you a little bit of a recap here and just remind you that anything that starts with the pound symbol, or the hashtag, if you will, has to do with the preprocessor in the C and the C++ language. So what that means is when we see a pound symbol is we're doing some sort of textual replacement. And I'll go ahead and show you with the compiler what that means when I do what we've been doing in pretty much all of these lessons when we include a file here. So when I include the IO stream, the header file that's in our system directory or part of the standard library, what I can do is do g++-e, and then this file here, main.cpp. And what this is going to do is it's not going to compile our actual code, but it's going to pre-process our file. That is, it's going to do all the textual replacements before we compile the code into machine code that our machine understands. And when I go ahead and hit enter here, you'll go ahead and see that there's a whole bunch of other stuff here on our output. And we can see our main, for instance, and return 0. That's exactly the same that we have on this left side here. But again, this is all of IO stream here. And again, just to give you a little bit of a better output, I'm going to go ahead and rerun this command with NL. So you can see that, well, there's about 20,000 lines of code here in IO stream in the header file. Of course, that's sort of optimized and it gives us great functionality, but that's just to show that we're really bringing in a lot of code sometimes when we bring in and compile these libraries. So anyway, that's the textual replacement that is going on here. So with that said, that's not the only thing that we can do though. We can, of course, include files to copy and paste in code from locations, but oftentimes what we're going to do is define symbols and even functions, which are effectively macros here in the C++ language. So if you want, you can go ahead and take a look at CPP reference here, and you'll find the page for replacing text macros here. And you can find this under the preprocessor section to find sort of a full listing here of the different types of things that we can do. But the main one that we want to talk about today is define here. And I'll show you a few different ways to use it. And then we'll go ahead and look at some special macros that have been defined for us here. So I'll go ahead and scroll down here and get us prepared for that. But what I want to go ahead and do is just show you a few examples here of how to use this. And the first one that you're going to run across and often see is the define macro. So let me go ahead and define something that I want to be replaced. And a common one to do is pi as an example. So 3.1415926, and that's as much as I've memorized in my life here. And what I'll go ahead and do here is compile this program again, just putting in pi and the end line here. And what this is going to do here is if I just, again, run with the preprocessor, so let's go ahead and do that experiment again with this code, we should see that, well, wherever I have capital P, capital I, and it's important that this is case sensitive, we should see a replacement here of this value. So I can go ahead and, again, run with the preprocessor, and you'll see here just over my shoulder, 3.1415926 here for pi. Okay, so we've defined a symbol here for pi that exists. Now, that can be very useful for us to do some sort of textual replacements. And again, you'll see this in sample code. Of course, these days, the sort of preferred thing to do if you want one of these values would be to do something like const expr. And if we're using pi, something like this. So just go ahead and at compile time, store or compute some value for pi, and then you get some type safety. So that's one of the reasons why we have to be a little bit careful with these sort of defines, because I don't know if pi is being treated as a float, as a double? Is it being converted elsewhere? Is it going to be implicitly converted to a integer somewhere? Is somebody casting this value? So that's why we tend to lean away from these sort of computations and prefer to get something like the type safety here with these types of expressions. So that's a little bit on the sort of trade-offs and what modern C++ is moving us toward. That said, again, we still have to be aware of defines because they are used in legacy code and occasionally helpful. All right, so let me go ahead and just get rid of this line here. Whoops, there we are. But I'll go ahead and leave it below here, and I'll just sort of say this is a preferred style versus, again, defining some constant numbers, for example. Okay, so what are some other things that we can do with this sort of define and this textual replacement? Well, the good news is we can actually do this within our actual command line here and actually pass in different symbols. Now, these different symbols here will change our behavior of our program. So what does this mean here? Well, let's go ahead and say if I have defined some symbol here, and let's just go ahead and put if debug, then we'll go ahead and print out pi. Or actually, let's just go ahead and say if debug, otherwise, I'll just print out not debug, just so we can get a little example here going. And what you can see here is what's known as sort of a conditional compilation here. So if this debug here, whatever this is set to, say 1 or 0, and we'll set this value momentarily, then emit this code here if debug is 1 and 0 if it's this code. So let me go ahead and save this, and what I'll go ahead and do is define this symbol here. Define, I'm going to do it all in capital, debug as 1 here. So again, you can go ahead and take a moment if you want to pause and figure out what's going to be generated here. So if you did that experiment, let's go ahead and run it. And you'll see, well, I've defined debug as 1. So if 1, which would be a true condition, then we're going to print out pi. But you'll not see this not debug statement printed. So again, this is a sort of conditional compilation where I'll often see the preprocessor used here. Now, just to go ahead and show you, if I make this 0, let's go ahead and rerun this really quickly, and you'll see not debug this time is omitted here. So that's the basic idea. Sometimes you'll see this in your code, things like if this is the Windows platform, if this is a Unix platform, do one path of code or the other to give you a different behavior. Okay, and that's the basic idea. Now, oftentimes you'll see debug, and the reason why I pick on that symbol is because folks will often not define it in their code, but they'll pass this as a command line parameter. So what you can actually do here is actually just do -d and define a symbol, again, being careful to make this all uppercase, and just set it equal to 0 here. So if I set it equal to 0, I should get the not debug, and I'll run it, and I see not debug. And this time, if I set debug, which I'll do just right down here, to 1, then you'll see the 3.145, etc., whatever this statement is here. So that's the different ways that we can work with things. So on the command line here, or actually within our code. Now, another way that folks will actually do this, and you'll see this known as a header guard, is it'll be something like if defined the symbol here. Okay, so if it's just defined, doesn't matter if it is or it isn't, then do something. Or you might see if not defined, if ndef, then define, debug, and then you could, do whatever else you want here, ndef here. Okay, so let's go ahead and try this example here. And this time what I'll do is I'll be careful not to pass in debug here. And let's just go ahead and play with our code a little bit. Let's actually just say if not defined debug, define pi here. So let's go ahead and just kind of set this up here. And let's go ahead and say if defined pi, then we can print it out. Otherwise, let's just print out no definition. Or actually, let's do a little bit better than that. Let's just do an approximation. 22 divided by 7 is roughly pi here, if my memory serves correct. So we'll just do something like that. All right, so now let's see. I'll go ahead and run this through with the preprocessor. And actually, let me give some better names here so we can follow this. So if not defined pi here, that's what I actually want to do here. There we are. Then I'll run this with the preprocessor. So if pi is not defined, define it and then print it out here. Otherwise, just print out some approximation. Okay, now I guess how do I know that this line wasn't printed out here? Well, let's go ahead and just comment this out. And let's go ahead and say, yeah, let's just get rid of all that. And now if I run it, well, it'll print out, well, whatever's in our code here. 22.0f divided by 7.0f. So we know that this is being compiled. So again, now we know about if not defined, defined, etc. These different things we can do. And again, this last example shows you that this is purely doing, again, with the preprocessor. I'm not running with any optimizations. 22 divided by 7 here. Okay, that's literally what we put in the code here. All right, so that's the sort of if def, if not defined, and some of these things. And frequently where you'll see these is known as a header guard. So if we pretend that this is a header file, the convention that you'll see is if not defined, and then you might put in, main, and usually these are header files, HPP, then define it, and then come to the very bottom of our code and do endif, something like that. That would be a header guard. Some of your compilers might also support pragma once as well, which is the equivalent for most compilers. Okay, so with that said, I've shown you a few things you could do for textual replacement. But I want to go ahead and take you back to CPP reference to show you some more advanced things that you can do beyond just text replacement and conditionals, but you can actually use functions with your macros. So let's go ahead and we'll scroll up here, and let's just go ahead and take a look at some of the things we have here. Now, if we look under this section, we get function-like macros, and they explain how to do some pretty cool things with defining basically a function here, or you can have a variable number of arguments. And there's some ways that you can do this and play around with if you'd like. But let me go ahead and just show you one sort of useful use case of a function-like macro, and then I think you'll understand the idea of it. Okay, so let me take us back to our little code here. And what I'm going to do here is define, again, something called log here. And this time I want to parameterize it so that I can actually take in some parameter. And let's actually just call it param here. And here's what I've got here. And typically I'm just going to write this on one line, though you can use an end line mark if you want to expand this. But what I want to do here is just do a cout. And what I want to go ahead and do is just type out log colon. And let me go ahead and change our screen a little bit so we can read this. And then I'll write out our parameter. And if I put the hash mark, that treats this as text here. And then I'll go ahead and put a semicolon here. Then I'll call the parameter, whatever it is. So whatever falls in between here, semicolon. And then I'll go ahead and just cout here an end line. Okay. So this is a little bit much in a line here, but let's go ahead and sort of take a look at what's going on here. If I actually use this, and what I'll actually do here is let's actually write a little function here. I'm just going to call a function here. Let's just call it add int a, int b, and we'll return a plus b here. And within our main function, let's go ahead and just do add 7 and 2. And let's go ahead and just make sure that this compiles here. Since we haven't tested this to compile. And actually, as I'm moving my window open over here, let me go ahead and show you that you can move these on a separate line if you want for your macro. So I'll go ahead and just do that here, just so you can see everything. And it's usually useful to put, one statement per line here, as you'll see that I'm doing here. And let's go with that here. Let's make sure that this all works here, so you can see everything just a little bit easier here with our macro. G++. This time we're actually going to compile our file, and it works. And I'll run it, and of course you'll see that we have pi, or rather our approximation of pi being run here. So let's actually, I didn't finish off, or I should add in the -d here, and then actually define pi 3.1415926. And now we get our better approximation here, and we have our add function. Okay, but now I want to actually use this log macro here. So how do I do this? Well, all I'm doing here, again, it's a textual replacement, is I'm going to put log here and surround our actual function call. There's no need for a semicolon. You can put it there if you want, but I don't like to because this indicates that it's a macro here. So what the preprocessor is going to do is essentially say, all right, where I have log here, I need to do a textual replacement. this is my parameter. This is the thing that I'm actually going to replace here, and copy and paste it to where I have param here. Now, wherever I have the hashtag here, it's going to treat it like a string. And wherever I have param, well, that's just the original argument here. So let's go ahead and try to compile this here. And I'll run it. And now what we'll see is anytime that I wrap around this function call, log, well, it prints out log and then performs the actual function, okay, which is happening here. And we're not really doing anything with it here, but I suppose we could print it out or, do something interesting. But that's the example of this macro here. Now, this can be useful for logging, for instance, and this is where you'll often see code where you want to do a series of statements, for instance, but just rely on the textual replacement. So sometimes what you'll see folks do is they'll have the sort of if, and again, using the preprocessor. So if defined debug, then do the log version, else just do, something like this here. And end if here. Okay, so let's go ahead and try that. So we're going to have our non-logged version. So if we run this here, we just get our pi printout. But if we define some other symbol here, and let's just go ahead and do it where we had pi here. I'm going to define debug here. Doesn't matter what value I give it, I'm just going to define it and compile it. Now we'll see that we're getting the logged version here. So this is one instance or a way that you can sort of switch around your code. Again, this is going to make your code a little bit cluttered, so I don't know if it's necessarily the best, but it's an example of some things you might see on occasion. Okay, so with that said, we've got this little macro here. Now, what other types of macros do we have that could be interesting or that are going to sort of inject code into our compiler that might be useful? And just to go ahead and show you how we're injecting things here, let's go ahead and run with our preprocessor. And I'm going to define our symbol, debug, just so you can again see how this log line got expanded out. Okay, just so you have a reference. All right, but on to the next thing here. And you'll see this is quite useful here. There's some reserved macros here for file, line, date, and time. But let me at least show you file and line. Those ones are relatively interesting. So something you can do if you want to build a little bit of a debugger here is I can actually come into my add function and I can actually print out here the file that I'm in and the line here. And let's actually do that with 2 underscores. And let's go ahead and print out a colon here. And that should do the trick here. Okay. So let's go ahead and now compile this. With our, let's actually do the compilation here. Yeah, let's go ahead and do with the debug here. One little syntax mistake here. Need to put my quotations. All right, let's go ahead and now rerun. Missing one set of arrows here. There we are. All right, so now if I run this, what you'll see here, and it's a little bit cluttered, but after or within our function here, add, it's printing out here the line at which we're at, 19. So we can see that right here. And the file that we're in, which is just main.cpp. So this can be a little way to sort of debug your program. Okay, so let me go ahead and just clean this up a little bit here. Let's just comment out our debugging. I'll leave it here just so we have a record of what we've done here. But if I just call the add function, for instance, and let's go ahead and, let's just compile it here. Here we can see clearly what function we actually called here, which again, I think it's kind of a neat thing to have. So these are predefined macros in any sort of source file that we have so that we can figure out exactly what our location is and exactly what file we're in. And you can use this to sort of create a little trace of your program of which functions are executing. Now, I will come with a caveat, and I'll show you in a moment, that C++23 is going to get some more interesting stuff related to stack traces and so on, so you don't have to use these. But one feature that C++ does have, and we'll go to CPP reference, is this source location that you can use. So this can sort of replace some of these macro functions like line and file, and instead you have this object here for source location. So there's a little example here. I'll go ahead and type it out so that we can see it. Now, one caveat, I don't have a compiler that's going to support this, but I'll still put it in here. So source location here is for the header. And I'll just go ahead in our add function here. And what I'll do, or a typical way that you can implement this, is before our return statement. So let me go ahead and just comment this out here. Let's go ahead and I'll put the caveat needs C++20 for this feature. But what you'll do is standard source location, and we'll just create a location. And then typically how you use this is you do standard source location current. Okay, and this gives you some object here that's going to give you the current location here. And then we can actually use this with cout here. And let's go ahead and do location, and just looking at our documentation here, we have line, column, file name, and even function name. Okay, so let's use some of these here. Let's try line or location, excuse me. Current. Let's actually just do current here. That constructs the new source location here. Let's go ahead and try that out. Let's see what that gets us here. And then we can play around with line or column or these types of things here. Right. So let me do this here. Now, again, just to show you, I'm going to try to compile this with C++20. I don't think my compiler supports this right now. So what I'm going to go ahead and do here, just for this example, is let me go ahead and just copy and paste this into Godbolt. So let's just print this out here. All of our text. Oops, need to make it a little bit smaller so I can copy and paste. Bear with me for one moment. Let's go ahead and just enter exit tmux. And just do a quick copy and paste of our entire lesson. And one of the reasons why I really like Compiler Explorer is if you change the compiler to trunk here, you'll get one of the latest versions, and then make sure that you change to C++20 here. And let's go ahead and see what we've got here. If I try to run this, just a few source errors here. Let me actually just change this to .line here, just following their example here, and it's a function. And we get some nice highlighting there. And we'll actually see the output here that we're at line 23, where I got this location from. Let's actually get some other information. How about, let's see, function. And I believe it's function underscore name. There it is. Underscore name. And make this just slightly bigger for you so you can see. And now you can see that we're within the add function, and it's giving us the parameters. It's giving us a line number. So you could format this or play around with it as you like here. All right, so let me go ahead and just make this a little bit bigger so you can get one more look at this. And again, this is a more useful or sort of a more type-safe way than relying on those macros in your compilers. Again, this source location, so if you have a relatively recent download of Clang++ or G++, so I should probably update mine, you can use this technique here. All right, folks, so that was a bit of a monster lesson here showing you a variety of different things you can do with macros and C++, just general text replacement tools, why we might or might not use them, and then some of the more modern stuff that's coming, things like source location. And as mentioned, there are going to be other stack trace features available in C++23, so make sure that you take a look at that, and you can subscribe here. Eventually, there will be a video on it, I'm sure, or if you'd like that, make sure to comment below. And with that said, thanks for your time and attention as always, folks, and we'll see you in the next one.